This is for 8.4 geometric series. We're going to take a look at a few different letters from number 1, starting off with letter G, where we are given values for T2 and T5, and we're trying to find S6, the sum of the first 6 terms. It would be very helpful if we had a value for R, our ratio, and given that we have T2 and T5, we can find one pretty easily. We know that T5 divided by T2 is going to be a times r to the power of 4 over a times r, or equal to r cubed. We can also kind of logic that out just by knowing that we're starting with T2. We have to multiply by r 3 times to get to T5, so you may be able to jump straight ahead to knowing that r cubed is equal to T5 over T2. And we're just going to put in our values for both. T5 is 3 over 2, and T2 is negative 12. So we're doing 3 over 2 divided by negative 12, or times 1 over 12. We're going to get negative 3 over 24, which we can reduce to negative 1 over 8. The one thing we do have to be a little bit careful about is that's our value for r cubed. So we need to take a cube root of this for r. It's going to be negative a half. Now that we have that, we can use our sum formula. So we can use the formula for Sn. I've got it up here. Since I know I'm finding the sum of the first 6 terms, I'm going to go ahead and write it out using 6 instead of n. So we'll find S6. It's going to be equal to our first term a times 1 minus, for my r value, since it's negative, I'm going to be a little bit careful and put it in a bracket just because our sign could change depending on the exponent. Negative 1/2 to the power of 6. And this is going to be over 1 minus negative a half. Now, as I'm writing this out, I notice that I'm going to need a value for a as well, which I'm not given. But because I know my second term, it's actually pretty easy to find my first term a, and maybe I'm just going to do this off on the right side. I'll just slide over slightly so we can do that. A is going to be my T2 divided by r. That's kind of the definition of T2. It's going to be a times r. So if I take my current T2 value, negative 12, and I divide it by negative a half, I get positive 24 for my a value. Now this would be a good time for you to pause the video, try and solve for S6, and then unpause when you are ready to see the solution. So I've put in my a value, and I've just cleaned up the bottom a little bit and combined whatever I could. This can all be entered in a calculator, especially with that large exponent on a fraction. You're sometimes going to hit numbers where you will just need a decimal. In this case, it works out pretty nicely, and if we calculate this in our calculator, we are going to end up with 15 3/4, or 15.75. All right, let's go ahead and take a look at the next one. For I, we're given r and S7, so the sum of the first 7 terms, and we're trying to find the first term, T1. We usually refer to it as a, so I'm just going to leave a little note of that. T1 is equal to a. And since I have a sum given to me, I know I'm going to need to use the sum formula. I have S7, so I'm going to write my formula for Sn using S7. It's equal to a bracket 1 minus r to the power of 7. And that's going to be over 1 minus r. And I can put in my value for S7 and my value for r. If you wanted to rearrange this to solve for a, you could do that before. I usually just plug in all the numbers and solve for a afterwards, but your choice, whichever works for you. Go ahead and pause and try and fill in what you can. Here's what it looks like with our given information put in, and then we want to put this into a calculator and rearrange until we solve for a. I'm going to leave those steps for you, but we do end up with a final a value of 64. Okay, and now let's go ahead and look at k. This one is switching things up a little bit. We're given the first term and the third term, And we're given a sum of the first x terms, but we're trying to figure out how many terms that's a sum of. Let's start off with finding our r value. Since I have my first term and my third term, it's pretty straightforward to find this one. My third term over my first term is going to be equal to r squared. So 18 over 2, or 9, is my r squared. My r value is 3. Now, because my first term and my third term are exactly 2 steps apart, I could have had a positive or negative r value. If we multiplied 2 times negative 3, we would get negative 6. Times negative 3, we would get 18. That works as well. But luckily, the original problem tells us that r is positive, so we know which r value to go with. Now, I'm going to use the same sum formula, and I'm going to fill in whatever I know. But this time, I don't know my n value. I can put an x in there for now, I guess. But I do know that it's equal to 19,682, so let's write that out. 19,682 is equal to our first term 2 times bracket 1 minus 3 to the power of n, but I'm going to put an x for there since we're calling it x apparently, over 1 minus 3 is negative 2. And I'm going to do whatever I can to kind of reduce this a little bit. I can divide out by that 2. I can maybe move that negative. Eventually I'm going to be solving for x, so I'm going to try and rearrange this so I have 3 to the power of x by itself. I'm just going to go ahead and reduce out those 2's, and I'll just change the sign on the 1 and the 3 to the power of the x to account for the negative sign. So we have 19,682 is equal to negative 1 plus 3 to the power of x, and I can move that 1 over to the other side as well. Let's just slide this up a little bit. So 19,683 is equal to 3 to the power of x. If this was a really nice number, you could probably guess it within a few guesses, but just in case it isn't a really nice number, or it requires a lot of guesses, we're just going to use a log for this. So you can either take the log of both sides of the equation, or you can rearrange it as log base 3. 19,683 is equal to x. Go ahead and pop that in a calculator by dividing your logs. Okay, and we should get a value of x equals 9. So that means that our sum is the sum of the first 9 terms. A good check is that you actually ended up with a whole number and not a decimal or a negative number if you're finding the sum of the first x terms.